Alrighty, folks. Today in section 10.5, we're going to take a look at finding the area of a regular polygon using trigonometry. Now, the big idea here is, remember that I can draw a bunch of isosceles triangle in any regular polygon. If I can find the area of one of those isosceles triangle, I can just multiply by how many triangles I have, and that'll be the area of the regular polygon. Okay, below, I have a whole bunch of steps that you can kind of, if you want to write down, you don't need to, but these are just kind of the explicit steps on what it takes to find the area of a regular polygon. But I hope that it's kind of self-explanatory on how we're going to find the area of the triangles. Now, again, in the last class, we talked about finding the area of equilateral triangles, squares, and regular hexagons. Now we're going to take a look at some shapes where we don't have special right triangles in them. Okay, the first one, let's take a look here. Suppose I want to find the area of a regular pentagon. All right, so taking a look at this, I've got my regular pentagon here. I know that the side length is 7 right here. I'm going to use that to find the area of this pentagon. So the first thing I need to do is, well, again, I know I'm finding the area of a triangle, so I need to draw a triangle in here by drawing 2 radii in. So I'm going to draw one from here to here, and one from there to there. Okay? Now, to find the area of this triangle, I know I'm going to do area equals 1/2 base times height, right? That'll be the area of the triangle. Well, if I multiply that triangle by how many triangles I have, which in this case is n, right, where n stands for the number of sides, I remind you that the number of sides has to match the number of triangles that can be drawn. I can start filling in my numbers. Well, again, because this is regular, I know that this base of the triangle is 7, so I know that I can go with area equals 1/2. I can put a 7 in for my base. I don't know my height of the triangle. In fact, it's not even drawn in yet, so I'm going to leave this empty. And I know that the number of sides that I have is 5, so the number of isosceles triangles I'm going to have is 5. Okay, so now my target is to find what this missing height of the triangle is. To draw, to do this, I first have to draw the height in. And again, remember that the height of this triangle, when we're talking about regular shapes, that's called an apothem. Again, it's going to be the altitude or the height. Remember that because this is an isosceles triangle, like this, I know that this height will do 2 things. It'll bisect this bottom side into 2 equal parts, and it'll also create a small angle up there that we can figure out. Now, I need to figure out what this angle is. To do that, the first thing I'm going to do is I'm going to create my central angle. So my central angle the measure of that is going to equal 360 degrees divided by however many sides I have, which is, or triangles I have, which is 5. When I do that, I get 72 degrees. So I know that this big angle up here, this big angle is 72 degrees, correct? Well, if the big angle is 72, how many degrees is just this little half going to be right there? Well, to get that top angle in my right triangle, that'll have to equal whatever the central angle is. Well, it's going to be bisected, so I'm going to divide that by 2. So it's going to be 36 degrees. So I now know that this top angle here, right here, is 36 degrees. Okay? Now, I've got this angle 36 degrees. Again, because this bottom is bisected, I know this little guy right here is 3.5 units long. And so now I can think I've got a triangle that looks like this, where this is 36 degrees, and this bottom side is 3.5 units long. I'm looking for the height of my triangle, the apothem, to call him H. Well, now here's where trigonometry is going to kick in. To find this missing side H right here, I know that I'm looking for this side, which is adjacent to this angle, right? It's adjacent to the 36-degree angle, and I'm given the opposite side of that angle. So I know that the word I'm going to use is the tangent. So I'm going to write the tangent of my angle, 36 degrees, equals the opposite side over the adjacent side. Call him H. I'm going to get rid of that little guy right there. Now to get H alone, we can do the old switcheroo. So H would equal 3.5 divided by the tangent of 36 degrees. Okay, so now that we have this height of my triangle, I can take him, all right, let's take this guy and let's shrink him down. I know whatever this value is, that's going to fit in here for that height, isn't it, right? So now I can find the area of the triangle by just doing the math on my calculator, right? And notice how I'm leaving this answer in calculator ready form, right? I can now say in my calculator, let's see here, I've got 1/2, so 0.5, times the base, which was 7, times it was alpha y equals enter. It was 3.5 divided by the tangent of 36 degrees, and that's not what I want. It was 3.5 divided by the tangent of 36 degrees, and then times however many triangles I have, which was 5. And so this answer of 84.303, this guy, that should be the area of my triangle. Okay? All right, and so that's my final answer right there. This is the area. Okay? Now, of course, don't forget to put your units squared. All right, let's do another problem. So in this problem right here, I've got a regular nonagon. I want to find the area of this guy. So the first thing I need to do is draw my triangle out. Boom, boom, right? I need to find the measure of this central angle up here. So 360 divided by, I've got 9 sides, so I've got 9 central angles. Well, that would be 40 degrees, okay? So this big angle up here is 40 degrees. But then I have to draw my apothem in. Let's get him out of here. I have to draw my apothem in straight down. Oops, sorry, kids. Let's try and do that again. So drawing that apothem in there, or the height of the triangle. Again, I know that he's going to bisect this angle up here, which is 40. So now this angle right here will be 20 degrees. He'll also bisect this bottom side, which is 3, so that's 1.5. I know then that I have the area of my nonagon will be 1/2 of the base, which is 3. I still don't know my height, but I know I have 9 triangles. So it's going to be 1/2 of 3 times the height times 9. And now I just have to find H. I'm going to draw my right triangle out to help me find H. This is 1.5. This is 20 degrees. And I can write the equation for tangent of 20 degrees equals the opposite side divided by the adjacent side, H. Doing the old switcheroo, I get H equals 1.5 divided by the tangent of 20 degrees. So I can take this answer now and slide it in for that height right there. Okay? Typing that in on the calculator, I'm going to go 0.5 times the base is 3 times the height is whatever 1.5 divided by the tangent of, oops, I did it again, 1.5 divided by the tangent of 20 degrees, and then times 9, right? So I get my area should be about 55.636 square units, okay? And so, hello, so my area then, my area would equal this many units squared. And that's that. Okay, so in general, a couple things. the rules for finding the area of a regular polygon. Again, we're using triangles to do that, right? Now, the only time, and we're using right triangles to find missing pieces, missing lengths that we're going to need to find the area of those triangles. Now, a big idea, only regular hexagons, squares, and equilateral triangles are special right triangles. All other regular polygons, we're going to have to use trig to find missing sides of the right triangle. And let me show you an example where you might get confused, or you might think there's a special triangle. Take a look at this last example. I want to find the area of this regular octagon. Now, in this picture, I've been given actually one of the radii of this regular octagon. Okay, so again, the first thing I need to do is I need to create my isosceles triangle. The next thing I need to do, I need to create this central angle. I'm going to take 360 degrees divided by how many angles I have, which is 8. When I do, I get 45 degrees. Now, don't stop there, because you think that this 45 degrees is special, right? Because that's a 45-degree angle. But then don't forget that the next thing I have to do is I have to draw in now my apothem. Well, what is that apothem going to do to that top angle of 45 degrees? Is it going to cut him in half, right? And so when I do this, I'm going to get 45 degrees divided by 2 is 22.5 degrees, okay? So this top angle here is actually 22.5 degrees in my right triangle. All right, now that I've shown you that top angle in the right triangle is 22.5 degrees, and it's not a special right triangle, I want you guys to try and find the area of that octagon on your own. Go ahead and pause the video, and then we'll go over the answer. All right, hopefully all of you did some work where you had to set up the sine equation. All right, here, everybody see the sine equation that you had to do to solve for that bottom half of the base. Then you had to multiply that by 2 to get the whole base. And then from there, you wrote a cosine equation to solve for the height or the apothem of your triangle. And then you plugged it all into this equation right here. And then lastly, you got an answer of 342.23968, well, yada, 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 square units. All right, folks, that's a screencast. We'll talk about it on Wednesday. Bye.